Okay, I just got a message. It got through to me finally. So I think we're recording now.
You are.
Okay, good. All right, so we'll go ahead and sorry. Okay, so we're recording now. So welcome everybody to the AGS meeting. Tonight we have Nirio Mendoza Inca, who's volunteered to give this talk and then was unfortunately had to be out of town. So he's going to be giving it from Denver, I think, somewhere distant place. And so, but we're glad that he could give the talk. Nirio is a Peruvian geologist. He has 20 years of experience in mining and mineral exploration. He's worked on a world-class epithermal and porphyry systems, lots of them in South America, Central America, and even in Iran. So he's really gotten around Jamaica. He's really gotten around the world studying these deposits. He has spent 6 years in leadership positions as chief mine geologist and exploration manager. He got his master's degree from the Universidad Nacional de, I'm not going to mess this up, yeah, thank you, in Lima, the MBA from the Universidad ESAN in Lima. He has a PMS degree from the University of Arizona, and he recently completed a MSc in Colorado School of Mines, and he joined Freeport-McMoRan's North American Exploration Group last October. So he's going to be talking about his master's work in San Juan's, and you can see his presentation. So I'm going to turn it over to Nirio. You ready to go?
Okay. Thank you so much, Phil, for a nice introductions about my person. And thank you for all of the audience connected online. Before to go with this speech, I'm apologizing for any inconvenience caused because I'm not in the room face to face. I would like to do the speech face to face, but I am out of state doing some field work, so that's because I'm doing online. Thank you so much. I'm apologizing for any inconvenience for those, please. So before to start with this talk about the geological mineralization of Red Mountain Lithocap in Colorado, conducted under Dr. Thomas Monique advisory. I would like to remember how I started this project. So I remember the first time when I talked about this project with Professor Thomas Monique, and one of his requirements to answer him about the, based on my experience about working in high-sulfidation systems, economic high-sulfidation system like in Yanacocha or Yanacocha in Peru or La Una Norte in Peru, what was the main characteristic for this kind of deposits? My answer by this time was the amount of silicifications. Obviously, the second question was, what do you think is behind this silicification over this kind of economic deposits? So these questions and others are going to be released during this speech. I hope also for you about after this speech, you can go back to your projects and to check if they are really barren or maybe mineralized ones. Should go to check your lithocap systems. Maybe that's the goal about this speech finally. Okay, so I'm going to start. So this is the agenda for this tonight speech. So I'm going to start with a brief introduction about advanced area lithocaps and high sulfidation systems, and what's the motivation behind this study. Then I will go with geological background about the districts and local geology. After I will go with some results and ending with some conclusions and finding out about the lithocaps, especially to be care when we're exploring in the greenfield operations stages. As we can see here, this is a Red Mountain localized to the southwest from Colorado. also southwest from Denver, driving from Denver to the Lake City town, which is the nearest town around the Red Mountain. It take like a 4 or 5 hours driving. So the Red Mountain is localized to the east from Lake City Caldera. This caldera belongs to Southern Rocky Mountain volcanic field, which comprising more than 24 calderas in these volcanic fields. And I think that's also, you can know very well maybe about the sunny side low sulfidation systems are also another high sulfidation system over the San Juan volcanic fields and other porphyry systems like a climax and Urat. It's inside this famous Colorado mineral belt, which is trending northeast, southwest, even passing to the north side of, I think, New Mexico. So I would like to do some introduction about what's mean advanced hydraulic and high sulfidation systems for those of you maybe is not so familiar with this kind of deposits. So as we know, this kind of deposits, advanced hydraulic and high sulfidation systems happening, and most of this linked to porphyry system. It was proved in many projects the typical assemblage, alteration assemblage sulfate like allunates, anhydrite, aluminum silicate alteration like kaolin, dikite, illite. And some of those deposits, it was also near to the top of porphyry systems. It was detected also presence of diaspora. It's formed in 5 different environments, as we can see here in this nice graph done by the heading question Arribas, showing 5 environments which might be possible to find this kind of lithocaps. Also, beside these 4 super kind of also lithocaps is possible to find, but more restricted. Another key characteristic about this kind of deposit, it's about that it's forming around with pH around 1 to 4 or 5, at least at deep 500-meter depth, and the temperature usually is below the 300 Celsius degrees. And the main ore mineral, it's minerite, plus minus leucinite, abundant perite, tetrahydroenated cubellate, and with gold intergrowing inside these previous minerals. But in the specific case of high sulfidation systems, bearing in gold, basically it's related to the hydrogen vapor rich with SO2 in HCl going to condensate into the groundwater, producing acid sulfate and chlorine-rich solutions with residual quartz, because this kind of acid-rich solution going to, as you know, it's going to leach everything leachable and just releasing the baggy quartz as a remaining mineral, as a remaining product. The subsequent liquid, the subsequent we can say stage is less acidic, right? And basically followed by disulfide liquid, which is going to transport gold, copper, silver, precipitating at voids of and microfractures of the previous residual quartz, like in this picture proposed by Silito. Obviously, the question was about how many of this kind of evidence of advanced lithocaps was observed in Great Mountains. So these questions are not going to be addressed during this talk. But what is the behind this? What is behind this? What's the motivation behind this research? So as we know, high sulfidation systems and porphyry copper deposits are the main commodity providers for gold and copper respectively. So more than 40% of worldwide gold productions came from epithermal systems, according to the numbers from 2023. more 60% of copper world production came from porphyry copper deposits, according to numbers to be Googling, according to 2022 for numbers. But however, there is not any clear geological clues allow peer explorers to distinguish barren lithocap for mineralized ones, especially during the greenfield exploration, I mean at first stage. And in Red Mountain, Red Mountain has the genetic feature like other systems observed in the world, and what can be studied to determine if its economic potential in Red Mountain. It's enough to detect vague silica like those reported in the world, like this one in Miao from Indonesia, Summitville in Colorado, and Lepanto. All of those are economic high-sulfidation systems with gold-bearing systems, like a Summitville, as you know, around 1 million ounces gold produced, I think, over in Summitville. And also the other question, it's enough to detect peripheral patchy texture like those from Mongolia, central Chile, in Turkey. This peripheral patchy texture as a transition to Milagros porphyry system in Laguna Norte here are also peripheral patchy texture detected immediately over the Cuferdale porphyry systems in Yanacocha, which is somewhere over here, and also over the Quebrada Cajon, it was detected peripheral patchy texture. So as a transition again to porphyry systems. In the case of Yanacocha Norte and Sur, which is here a big deposit for of you who don't know about these high-sulfidation systems, this Yanacocha Norte Sur pit, it was already detected some of this patchy texture, totally different from Cuferdale. So by the way, this picture from San Jose deposit looking to the north, looking to our Yanacocha Norte and Sur Oeste deposits in Peru. So tell me the question again, it's about how many of outcropping or suboutcropping lithocaps have been misinterpreted, and what are the options for geologists when commissioning two lithocap fields, especially during greenfield operations? So these questions are now going to be addressed during this talk. So going back earlier to this diagram showing talk a little more about the Red Mountains. So as I said before, the Southern Rocky Mountain volcanic field is comprising numerous calderas, as we can see in this diagram. This basically is northwest-southwest volcanic trend and dominated by Miocene, Oligocene age volcanic rocks and containing numerous low sulfidation systems like a Sunshine, high sulfidation system like also Summitville here, and porphyry system like a Climax Henderson. This volcanic field, according to literature, it was controlled by the Farallon plate rollback process. As most of you know, probably, the Farallon plate stopped subducting under North America craton around 40 million years old. Everything after is going to be related to Farallon plate rollback process. So by the way, Red Mountain, 23 million years old, is part of this rollback process effect. So Red Mountain from Lake Sierra Caldera is one of the largest lithocap in the southwestern of Colorado. Previous studies done by Bob and other authors reporting alunite date ages from 23, around 23 million years old. But it's interesting that neodymium, osmium, molybdenum dates reported also 23 million years old and 23.2 million, almost the same age like for argon. Please keep in mind these numbers because we're going to be discussed later the meaning of those. This is a map modified from Meher, Hong, Boff, and other authors. As we can see here, the Red Mountain lithocaps in place to the east from Big Lake Sierra Caldera, It's a perfect circular feature. Around this Lake City caldera, as we can see, there are numerous quartz vein-based mineral here, also ute mine, also golden fleece mine. Most of those are pre-caldera age, and some of those, according to the literature, has the same age like for Red Mountain, 23 million old. In the specific case of Red Mountain, it has, I'm going to go a little more detailed explanation here in the next slide. It has almost, Red Mountain lithocap here, as we can see, it has almost 4 by 4 kilometer area. And the central part, which quartz alunite, is almost 2 by 2 kilometer, surrounded by clay, quartz clay and clay alterations. There are two predominant lithology at surface, as we can see here. The rhyolitic tuff to the south in orange colors, and the pinkish one is the dacitic lava flow. In the central part, we can see here its presence of also numerous ferromagmatic breccias and some narrow dikes in again dacitic one also in place in the central part of Red Mountain. Most of these units are volcanic, and even this really tough it's belong to the explosive stage of Lake City caldera. The only intrusive reported was Alpine Gulch granite unit. So in the next slide, I'm going to talk about the A prime cross sections. This is the A prime cross section looking to the northeast. And the LC4, as we can see here, almost 850 meter length. So as a reference for the scale, this cross section is showing basically the lithology distribution and alteration distribution. As we can see in this cross section, the quartz alunite capping is look like only remaining just a small amount of those going downward with quartz clay. White clay patchy texture. If you are following, please check also the legend. And intermediate arealic, apparently almost ending in potassic alteration. Since lithological point of view, the dacitic racing mountain in pinkish ones look like intruded by also porphyritic dacitic units in light green. These ones cross-cut by later ferromagmatic breccias. Here. Even some of those, it was detected presence of vaggy quartz, even deep. The interesting observation about the ferromagmatic breccias is some of those even deep is presenting altrate fragments. These Alpine Gulch granite intrusions also reporting presence of turbulent breccia mineralized veins. So now I'm going to go a little more detail about the lithology. This is the rhyolitic sunshine peak tuff, basically fine intermediate tuff sequence and cross-cut or overlap by dacitic lava grazing mountain, which is a porphyritic unit basically. This is a piece of hand sample showing the porphyritic texture. In this case, even it's possible to find the alunite stage 3. It means basically a superior alunite cross-cutting the previous alunite 1 and 2 detected in this hand sample. The other unit, that is porphyry unit, is going to be cross-cut the previous one. This coming from deepest portion of the area. So the one of the key characteristics is the presence of sanidine surrounding phenocrysts, even though some of those with more than 3 or 2 centimeter size. In black colors, basically it's related to the secondary biotite and magnetite alteration, which is happening filling fractures and also replacing some matrix here, almost a phanetic matrix. This is a phreatic breccia or phreatomagmatic breccia because it's containing also this kind of probably juvenile matrix and some juvenile also fragment as a part of this phreatic breccia. This hydrolytic breccia cross-cutting all of the previous units. Also during this mapping, these samples came from survey. This is from logging holes. It's possible to detect presence of hydrothermal breccia. The main characteristic about those, it's as you can see here, it's full of oxide, hematite, goethite, jarosite, also some of those, and still magnetic. This is the dacitic dikes also with similar texture to the dacitic porphyry, which I already talked before. It has also similar surrounded phenocrysts of sanidine as a resultant of resorbed process during the magma evolutions. During this logging, it was detected the presence of fine-grained vitreous veinlets. This kind of veinlet, it was started observing around 283 meters. Some of those are very center line with pyrite, and also some of those were higher scale veinlets, like those observed here. Based on logging, it was observed at least two stages of veinlets. Well, as I said before, some of those in place in dacitic volcanic sequence, like this one, or also some of those cross-cutting the phreatic breccias, like in this breccia. However, no A or C veins was detected. Some micro photographies showing some presence of even quartz banded, subpolymetric quartz banded for some of these vitreous planar veinlets, or even with center line with pyrite here. This Apache texture detected in the drill hole. It was detected at least 4 intervals, starting at 530 meters. Basically, as we can see here, is our white, look like a white mica and clay patchy texture replacing potassic alteration. Looks like, as we can see here, this patchy texture, it's start happening or replacing or reacting in some of these microfractures. Finally, at the end, some of those are going to be completely replaced by white mica clay patchy texture. In some of those, even revealed by fine pyrite like this one or here. This is the hyperspectral scanning for this core slab. For the same core slab, it's confirmed what almost was observed in the previous visual logging. Yes, as you can see here, this is a nice patchy texture. It's a white color here, but according to the hyperspectral scanning, showing basically, if you see the legends, kaolin white mica replacement. If we see here, this is the remaining, we can say, potassic alteration, because as you can see here, the literature in the black pixels basically means for silica presence, which may be this one, but if you see biota is there, I mean, this is the potassic alteration silica biota and replaced by this basically smectite alteration with this kind of patchy texture. It's interesting how it's possible during this logging was detected at least 7 small ledges with baggy quartz. Inside this baggy quartz, visually it was observed presence of fine pyrite, ironite inside these bags, and almost absence of drusen quartz. It's, as you know, when you're exploring or trying to know the feeder of systems, especially in lithocap environments, it's very important to record this kind of contact as we can here. pointed by these white arrows. It's clearly conduct of vagi to the right and silica alunite to the left. This one's going to be probably pointed out about this like a subvertical feeder, just to follow up and maybe even deep this kind of feeder. So this is the hyperspectral core scanning for the same core slab as it was expected. The black pixels means for unclassified material. I remember tentatively say it's more than 60% of these core slabs correspond to the silica, which is baggy silica, with kaolinite and white mica in blue colors. Some also alunite, if you see it's pinkish color, some alunite in pixels, but also some peroxide, maybe both of them in less than 5% of total area for this hyperspectral core scanning. Okay, but what else? What else behind these things? What is behind this baggy silica? So it was done number of thin sections, especially under the area with baggy silica. So inside those, it was also basically juicy alunite. Alunite here, also alunite here, alunite, also juicy alunite, having the matrix with quartz clay and quartz alunite alterations. But we're still digging more details about what's happening inside this baggy texture. So what was done is, in order to prove if there's really alunite there, it was done scanning electron microscope. These two backscattered electron microscope images inside the baggy or bags going to show him basically alunite here, as you can see, alunite, also alunite as a druzy alunites. Only some small amount of quartz it was detected, like here. This backscattered image 8 belongs to the hydrothermal breccia, which I talked before. It was detected as well as affected presence of magnetite with hematite, and also in quartz alterations. Also presence of alunite, elongated alunite inside this hydrothermal breccia. So this backscattered electron image is going to show basically the type of sulfide detected during this job. It was also chalcopyrite with galena as intergrowing. Also, it was also presence of pyrite intergrowing sphalerite, even molybdenite, but not sulfosalt was detected. Also, it was detected presence of barytate and magnetite associated as a part of potassic alteration, even albite slightly replaced into sanidine. I mean the fresh sanidine here. It's also conducted automated mineralogy, mosaic image, in order to know what's the real minerals here. So prior studies state for most of these subvolcanic sequences in the area that they are potassic rich. It means it may mask the hydrothermal potassic alteration. Thus, we'll try to test here. Even during the logging or during this thin section study, it wasn't detected potassic alteration, hydrothermal potassic alteration. But what was detected was this one: presence of hydrothermal K feldspar truncated all of the previous primary potassic component of this rock. I mean, according to this automated mineralization, look like if you see the legends, look like everything's K feldspar, but not all of these are hydrothermal K feldspars, only small amounts. Like this one, detected surrounding as a halos for submillimetric or millimetric structure here. So we should be careful about using automatic numeration in order to differentiate which one are primary and which one secondary. I mean, geothermals, I mean. Also, it was conducted hyperspectral scanning. Before to describe with this one, so I would like to go and to show really how it's showing a nice sharp contact between if we see the literal Muscovite alteration versus kaolin and probably silica alteration here. It's very it's wonderful how hyperspectral scanning works. So this this hyperspectral scanning was conducted for a drill hole LC4. The length total for this hole is almost 850 meters. Once was done this one, it was finally established five clusters. At top, we have basically, please go below to follow up the meaning of this diagram. So, or the mineral. So, it was in the top, we have kaolinite, basically with some ironite, and really less than 1% of perfluorite in some area, some really narrow areas, as we can see in this one. The second cluster is basically white mica and some kaolinite. And the third and the most large, we can say it's a kaolinite white mica. And the third is the fourth cluster, it's interesting. It's showing up the biotite decreasing kaolinite and also increasing the presence of classic material for silica, white mica also. But around 730 meters here, the last cluster at the bottom is showing almost absence of kaolinite. It means no more advanced aerialic everything's happening. And basically, it's preserving here most of the, we can say, potassic alteration, but it's still overprinted with white mica or illite, which basically means some sort of intermediate aerialic alteration overprinting to the potassic alteration at the bottom. Do you see here the patchy? Patchy is really inside the patch area. We can see it's unclassified for silica, kaolinite, some overprinting, biotite, smectite, and illite. Also, as I mentioned, I think before, some of this baggy silica, small baggy silica interval, is showing presence of alunite and also some little amount of perfluorite, even not less than 1% for the area during this scanning. Also, it was sent we can say six typical samples from this project for total chemistry analysis from surface, subsurface, and at the bottom of the drill holes. It's interesting how it's barren for gold, silver, copper. It's barren for those, but it's interesting how moly is starting increasing at the bottom around 734 meters. It might be explained because it was detected presence of molybdenite during logging, and some of those it was took for osmium dating. Obviously, as was expected at surface in kind of environments, in the lithocaps environment, you will not see or almost barren for molybdenum. Bario, it's possible, also at the bottom, but in the specific case, it's even more, you can say anomalous for bario. So going back, these cross sections is trying to explain about how the only remaining part of we can say lithocap capping preserve. Even some of these baggy quartz, it was detected also, as we can see in these red lines for baggy quartz, even deep. So it means pointing to our probably feeder somewhere over here. Even it was detected presence of ferritic wedges with altered fragment like those showing here. Even some of those so deep, 641 meters around here. So an hypothetical 600 800 of lithocap, it was eroded. That's our only hypothetical ones, in order to prove the amount and the depth which was in place. This kind of lithocap, it's necessary to do maybe later microthermometry studies over this area. Since not A veins and no strong K feldspar alterations was detected, as he showed you in the previous slides, the K feldspar is only small submillimetric halos. Also, still open secondary biotite potassic alterations, especially here at the bottom. It's proposed that deep causal intrusion is still at depth, like this one in gray colors suggests for this case. Even for the alpine gulch intrusions, there are probably another intrusion, causal intrusion, which is going to be releasing like this kind of thermal temperature and mineralized veins at the top of alpine granite. So that's the we can say in summary the genetic model for this lithocap. In the case of specific case of red mountains, probably related to the missing causal intrusion at depth, which wasn't already detected, apparently, based on the evidence that I already talked. So we are almost ending in the presentation on above. So okay, so what's the implication of operations? We can conclude the potential to explore for high sulfidation system at red mountain is almost null. Most of lithocaps and residual quartz were eroded. We can preliminarily conclude also barren lithocap mostly dominated by druzy alunite and druzy quartz, therefore also constrained by amount silicification. Absence of high sulfidations, typical minerals, or maybe a mineral like enerate, leucine, titanate, it's not present in this project. White mica clay patchy texture can be associated to barren lithocaps. These are preliminary conclusions. So since no A veins from ductal lithostatic stage was detected, even K feldspar at submillimetric halo, we can say that we're still missing the causal intrusions. So, however, the Lake City caldera and rainfalls around look like excellent structural for magmatismal alteration. I mean, during our explorations time in the field, we should try to look for any rainfalls or any this kind of evidence at surface, small or big scale, which might be indicator for any kind of maybe mineralizations or even magmatism around. So the hyperspectral scanning shows at least 400 meter of lithocap preserved below subsurface. At depth, phyllic and potassic alterations look like are printed by the advanced areolic and intermediate areolic alterations. Some, in the case of red mountains, it's showing some characteristics similar to the mineralized ones. But however, as it was expected, the first stage, which is going to be affected by early acid state alteration from vapor condensation, which is going to be produced some baggy quartz. As I mentioned, at least six or five ledge. And these ones are just showing alunite. That subsequent liquid stage didn't occur, so therefore there is no druzy quartz in barren lithocaps. So therefore also is restricted silicifications happening because we're missing the liquid stage. Also, if we are missing the liquid stage, going to be absence of mineralizations like enerate. Obviously, no C veins because C veins link it to basically to liquid stage. Also, the new chemistry is showing barren for gold, silver, and copper. However, it's anomalous for barium, especially at the bottom, at the top, and moly. It's for sure anomalous at depth. So this is the last conclusion finding for this research. As we know, according to literature, as a transition to porphyry system, it's typically peripheral patchy texture, which according to authors like Hedingquist and Arribas and other authors, the peripheral patchy texture, it's happening because the white mica muscovite is going to react with where there's a lot of silica material. And in liquid stage, going to finally produce peripherate ones. But in the case of red mountains, it's showing patchy texture, but under this stage. I mean, basically, compound the main component of the patchy texture in the red mountain is white mica, probably elite muscovite. So what's happening? Why is happening or this kind of white mica patchy texture in red mountain? Because we are missing the liquid stage. That's our preliminary conclusions. Well, it might be also because the new red osmium dates reported 26 million years old, similar to argon-around alunite dates done by Bob. It means if the both ages are similar, it means basically a rapid, quick cooling process happening in the area. Also, it means a short period geothermal alteration stage happening around the red mountain. Since vaggy quartz ledge, even some of those so deep, and also presence of phreatic breccias containing also silicified ramens, we can propose that the system is still open depth. So since AE veins are absent and submillimetric cave filler halos was only observed, it was suggested that we are still missing the cause of the intrusion at depth. I would like to say my public acknowledgement to my advisor, Dr. Thomas Monick, who worked very hard with me to finish this job on time. Also to my committee, Dr. Katarina Pifan and Mary Doherty. Also special mention to Dr. Shoshan, Antonio Rivas, and Jeffrey Hedingquist, when we're discussing about the lithocaps and the meaning of basically white mica patchy texture instead of why we don't have in this project proof like patchy. Also, Dr. Holstein, who conducted ring osmio dating. I can see online, I think also President Dr. Mario Gomez, he helped me since the beginning when I was working in Denver Federal Center, where most of these drill holes are stored there, and all of this person listed here. So thank you so much. I'm ready for any questions.
If you have any questions, just unmute yourself and speak up, or you can put things in the chat if you aren't comfortable speaking.
Hola, Nirio. Hace mucho tiempo. Good to see you again.
Oh, Jerry.
Yeah.
Hi. I was looking for you in around Tucson, but I couldn't meet you. I hope so.
Yeah.
Hi.
Yeah, it's been a while since we worked together. Good presentation. Yeah, several questions come to mind that could be other avenues for investigation on these types of systems. One is that the very texture of alunites tells quite a bit about the temperature and depth of formation, and you can distinguish supergene versus hypogene alunite by some alunite textures. I have some graphics. I can't pull them up just now to share with that. But one thing you mentioned is that you hadn't seen any A veinlets. And in my experience, and also because A veinlets represent deformation that happens concurrently with formation of the veinlets in the host pluton, the B veinlets can extend beyond the host pluton as much as a several hundred meters above and beyond the source, the progenitor pluton, and because you won't get A veinlets in the wall rock, but B veinlets, due to the nature of being introduced into brittle rock, those can extend beyond that. You didn't mention whether you saw any B veinlets or not. Any ideas about that?
It looked like it was I was discussing about it with my advisor, but it looked like we have some sort of V veins. I see in the here. I can go back maybe.
Yeah. Yeah, you mentioned some vitreous veins. I wasn't quite sure that those were
These
genuine V
vitreous veins look
veinlets.
like V veins because in some of those was planar with centerline parent, but it's not a typical ones. That's my point. So it's not a typical V vein with you can see a little granular texture, but in this case look like we can say subtype V veins, fine grain, very fine grain texture. Even some of those, as I show you in the thin sections, look like some of those sort of banded. They look like banded
Okay.
V subtypes. Yes, it was observed.
Okay.
I don't know, it doesn't allow me to go back to show this picture that.
I remember the picture you said they were vitreous veins, so I wasn't quite sure
Yeah.
if that granular, very
Yeah.
distinct texture within the B and A quartz veinlets have. They're so distinct. Yeah.
Yeah, so that's most veins look like a V veins, but it looks like happening, but it's not a typical one. But we have with center line and planar.
Okay.
V types, we can see that.
Okay. I'll let somebody else ask questions. I do have more, but I'll I'll yield the floor.
Nirio, I probably missed this, and I suspect you presented it. What was the timing of the volcanism with respect to the secondary mineralization?
You mean the secondary mineralization? The only secondary mineralization detected alteration we can say it's alunite. So we don't know. I'm not sure if somebody dated, but what we know for sure is we have this alteration almost the most of this subvolcano is happening around 3 million years old. It was based on renewable dating and also argon dating in alunites. For the hypogean, I mean hypogean alteration. So the supergene, which might be alunite, I don't know for sure. For secondary
Okay,
alunite.
thank you.
Hey, Nirio, I have a quick question. Nice presentation, by the way. It's good to see you. It's been almost a week.
Kyle?
Yeah, it's Kyle. Hey.
Oh, I recognize your voice.
Yeah,
Thank
sorry.
you to be
Hey.
here.
Yeah, good job. I'm surprised there's drilling out here, given the geopolitics of mining in Colorado. I'm guessing the core is old. My question is, when was this drilled and by who?
Okay. 1980s, it was done by the government for the government. I think for geological survey from Colorado, I think, but it's from the government. It's coming from 80s.
Thanks.
19, yeah. Thank goodness it's still storage. All of these are storage in the federal government center, which is as we use these samples for this study. Any question more, please?
Questions and comments. There've been quite a few other studies that during the last mostly 5 to 10 years about using proximity indicators to get toward the center of to determine where the center of the deposits are relative to lithocaps and the outboard environment. But also, there's been other studies for fertility indicators of for these deposits within lithocaps. There is one using one that I do know of using vanadium-scandium ratios contained within rutile in lithocaps. Says it's not real precise, but as a qualitative measure of the possibility of having a fertile magma that seems to work or give a guide for the fertility of magmas in both the porphyry and epithermal high sulfidation environments. if enough lithocap is preserved to capture some of those rutiles. I don't know if that had been any part of discussion of your thesis work or not.
No, we didn't discuss about this one. Sorry. So it was focused about what's behind the vaggy. In this case, when I was in the field at the first time, I thought looked like a, when there is micro scale, I don't know, you can confuse with also with druzy quartz, but at the end, it wasn't alunite. Sorry, it wasn't alunite. Sorry, quartz. It was only alunite. So we should be carefully. That's really because if we are in the, exploring the field, we should be carefully checking at the first day, especially in the greenfield exploration, try to look for druzy alunites. Sorry, for druzy quartz instead of druzy alunites to try to preliminarily say it might be barren or economic lithocaps.
Yeah, back, that's showing my age and history, but about 35 years ago, I had the opportunity of working on Red Mountain 3 by Ouray, Colorado. And that had preserved lithocap that did have gold in it. But there had been previous drilling for a copper moly deposit at depth. And as it turns out, yeah, it was lacking the intensity of mineralization at depth, but it appears that the gold migrated preferentially up into the lithocap, but there was just portions of it preserved. And then going back to the question about geopolitics, yeah, that'll never get mined up there. There's probably 250,000 ounces that will never be touched.
Yeah, right. I talk about this project with Professor Thomas Monick and also Professor Steve Enders. He mentioned about this one. There are like around 1 million or even more of ounces gold in the Red Mountains tree, which is to the west side of this area where I already talk or research. It's in the other west side. It's like
yes, yeah, it's separate. Yeah, it's a separate part of the edge of, I believe, the Silverton Caldera there. Yeah. But it's a very similar looking environment to that, but there is silica lithocap preserved, volumetrically minor, but it does appear that the gold had, due to sulfidation state, perhaps temperature as well, preferentially kept migrating to higher environments outside of the porphyry environment. That would require further study, but that I think is the frontier of further investigations into the disposition of metals deposition between the porphyry and epithermal environment is getting firm measurements of what exactly the sulfidation state was, as well as the temperature within those regimes. Because if the magma in the porphyry pluton is hot, the metals are still soluble and will migrate farther upwards. And that's what happened at Yanacocha.
Yeah. Yep, good comments. Yeah. Observations, Jerry. Thank you. So I'm taking note to be also.
That's just for further study. That's I think where the frontier still lies to categorize and advance the difference between productive porphyries and where the deportment of the metals will be in those environments. Okay. Well, good talk. I'll let somebody else talk now. Okay.
Hey, Nirio, this is Paul Warren. How are you doing?
Hi, Paul. Nice to see you. How are your life near to the beach?
Well, as you know, I'm pretty far from the beach, but we'll get together when I get back home. I have a question about all those veins, like at the Ulay mine and all around in there. Are those systems older than this one at Red Mountain, and Red Mountain comes roaring up through that anything that's pre-existing, and what are those related to? You know anything about that kind of stuff?
The UTO mine and the other to the west, because there are many veinlets. I mean, it wasn't detected for me or recorded because I didn't have time to go over those. But what I know is most of these UTO mine to the west are are older than Lake City Caldera age because it was cut definitely by the Lake City Caldera. But I think the nearest gold mine in the same age like for Red Mountain or Lake City Caldera is only one. I think that the Fleece Gold Mountain, the Fleece Gold, yeah, the Fleece Gold mine. That's the only one I think has the same age, but the other one is older than Lake City Caldera.
So all those veins, the Lake City Caldera just ripped right through and just punched that, and then it looks like the Red Mountain came up at the edge of the Lake City Caldera. It looks like it came around one edge of it. So just much younger system, I guess.
Maybe, yeah, but as I restate, the only one is a Golden Fleece mine is that I think if I'm not wrong, is the only with the same age like for Red Mountain, 23 million years old. The other one is oldest. It may explain also because why these red mountains look like a barren, because if we have productive systems linked to the also productive porphyry system at depth, for sure, as we know, according to our experience, you will find more veinlets around this, like even starting so far with, with polymetallics and other type of deposits. But in this case, the only one is the Golden Fleece mine. Look like the same age because according to the studies. Anybody else, please?
There are a couple of comments in the text about in the chat
you,
about the Red Mountain number 3, but I don't know if you can you see the chat, Nirio?
let me see.
I don't know if they they don't necessarily require you to comment, but if you want to.
Okay, I'm going to reading. The most recent, no. Amoco minerals drilled on Red Mountain, also potential manto type deposits by iron tongue flags just below Red Mountain. I don't have any comment about this one because I'm not familiar. Where is iron tongue flags?
Okay.
But you're right. It's Amoco minerals drill Red Mountains. Yes, you're right. Probably I was confused. It was in the geological survey from Denver or from Colorado.
Okay, well, if we have no more comments, I want to thank Nirio for his presentation and look forward to seeing you in person in Tucson when you're back around. And thanks everybody for wading through the logistics and finding the meeting. Appreciate it.
Thank you. Thank you to you, all of you, for to be present in my presentation. Thank you, Phil. Thank you.
Thank you, Nirio.
Okay.
Thank you.
Adios, buena suerte.
Gary, please, I need your cell phone number later.
Okay. Yeah, I can
By email.
I can give that to you. You can find me on LinkedIn.
Okay.
All right.
I want to say hello. Thank you, Gary.
And we can exchange info there.
Yeah.
Okay.
Okay, I'm going to end the meeting.
Okay.
Thank you, Nirio.
Thank you so much. Thank you to all of you.